ब्रेक करता हूँ, ठीक है।
The structure of matter. Atomic theory and structure. Evidence for atomic theory. John Dalton performed chemical reactions and carefully measured the masses of reactants and products. Dalton proposed that all matter is composed of subunits called atoms. Atoms have different identities called elements. Elements combined together in definite ratios to form compounds. Atoms are never created nor destroyed during chemical reactions. Thomson. J. Thomson observed the deflection of particles in cathode ray tube. He concluded that atoms are composed of positive and negative charges. He called negative charges electrons, and he suggested that the positive charges were distributed in islands throughout the atom, like raisins in raisin bread. Some people at the time called the plum pudding model of an atom. Millikan. Robert Millikan used oil drops failing electric field of known strength to calculate charge to mass ratio of electrons. To summarize, the charge contained by a single electron. Rutherford Ernest Rutherford fired alpha particles that he knew to be positively charged through thin gold foil. Next page. Rutherford measured the resulting scatter patterns of alpha particles after they hit the foil. He found that most of the alpha particles moved right through the foil, were deflected slightly. However, some alpha particles were deflected at large angles, as though they had collided with a heavier object and bounced back. He concluded that positive charge and the mass of atom are concentrated at the center of an atom, and that the rest of the atom is mostly empty space. This directly countered Thomson's plum pudding model. Max Planck determined that electromagnetic energy is quantized or composed of discrete bundles expressed by the equation below. Energy and electromagnetic radiation E equal to h nu, or since the C equal to h nu, C equal to V nu, V lambda, E equal to hc by lambda, E capital E, energy of the photon in joules, h small h, Planck's constant 6.63 into 10 to the power minus 34 joule seconds. Nu v, small v, frequency of light, second inverse 1. Lambda, wavelength of light in meter. C, speed of light, 3 into 10 to the power 8 meter per second. Bohr, Niels Bohr, applied the idea of quantized energy to show electrons exist around the nucleus at the fixed radius. Electrons with higher energy exist further from the nucleus. Bohr model is accurate only for atoms and ions with one electron. It was clear that a more complex model was needed to explain atoms with multiple electrons. Electrons give off energy in the form of electromagnetic radiation when they move from higher level or an excited state to lower level ground state. The energy represented by light using Planck's equation represents difference between two energy levels of the electron. De Broglie, Louis de Broglie identified were wave characteristic of matter by combining Einstein's relationship between mass and energy, E equal to mc squared, and relationship between velocity and the wavelength of light, E equal to h nu. This shows that all particles with momentum have a corresponding wave nature. De Broglie wavelength of particles, lambda equal to h by m nu v. Lambda equal to wavelength associated with particles in meter. M equal to mass of particle kg. H equal to Planck's constant 6.63 to 10 to the power minus 34 joule seconds. Nu equal to velocity of particle meter per second. M nu equal to momentum of particle kg meter per second. Heisenberg, Werner Heisenberg, in the early 20th century said that it is impossible to simultaneously know both the position and the momentum of electrons.
Sorry, you want to sign up for a free phone by any chance? I got them on me right now.
For small particles such as electrons, this uncertainty suggests that we need a wave model rather than Newtonian model to understand their behavior. Erwin Schrödinger, in the early 20th century, attributed a wave function to electrons. The wave function describes the probability of where an electron might exist. The regions of high probability are called orbitals, even though they are more like clouds than orbits. The orbital of each electron is described in Schrödinger's equation. These orbitals can be described as S, P, D, and F orbitals as used in electron configurations described later in this chapter. Thank you very much. That's it for today. See you in the next lecture. Lecturer Instructor Ankita Mali. Goodbye.